right, so this is me. I'm Simon. Hello. I'm a developer tooling engineer, which means I build tools to help you build applications and help you build applications better and build better applications. And it's nice. I am the creator of Quirrel, which is a job queuing solution for serverless deployments. Please check it out. It's very heavily focused on having a nice developer experience. And I'm also a maintainer at Blitz.js, which is a JavaScript framework that you can use to create full stack React applications. And I might be biased, but I really like it. So try it out. You can reach me on Twitter or GitHub under the handle @Knott. And that is a 0 in there because zeros are cool and lead speak and it's not an O. Yeah, got that out of the way. And the talk today is called Designing a Library for Real-Time Queries. And the subject is RTW, a proof of concept library that I built together with two friends, Jan and Paul. Both of them are sadly not here tonight, but we'll talk about Jan in a bit. But that's the subject. The real topic is how to design and how to build libraries so that they're good and easy to use. And we're going to talk about questions and ideas and concepts that are helpful in that. RTW is really a proof of concept library. You shouldn't go out tonight saying, this is the best library I've ever seen. You should not go out to use it in production, but you should go out having learned something about how to design a library. Right? Cool. I'd like to introduce you to Jan. This is Jan Wilhelm. He would have been here tonight, but he sadly couldn't come because he's at a team offsite with his team. He is the technical founder of Chat, which is a Berlin-based company. It's a non-profit who do chat-based psychological counseling to young people, to students, school students, university students, everyone below 25 years of age. And I mentioned it's chat-based, or it's like a chat-based service for psychological counseling. Users or like students communicate with them via WhatsApp, but their counselors use their in-house built chat management application. So what Jan builds is mostly a chat. And because he does that, and he does that like really good, he's super obsessed with all things real-time. It's a chat, it's real-time, like it needs to be. And the problem is, real-time is not as easy to build as it should be. It's kind of hard. And we went out to think about, well, how could we make this better? And I brought you a small overview over what the market of concepts, frameworks, database, all these things for real-time looks like at the moment. Let's talk about concepts. If you want to build a real-time application, chances are you have a normal application before and then you build on real-time, because you didn't think about it in the first place. You build on some WebSockets and you just do something homegrown, but there's no real concept or something behind it. You could use polling. Polling is real time in disguise and worse in every way possible. Polling means you tell your clients to just make the same request every 50 seconds, and then you call that real time. It's not good, but it's fine for a lot of cases, to be honest. And there's things like event sourcing, where the idea is to really model your application so that it's based on a stream of events and you can do things, and event sourcing is cool, but not there yet for most applications. There's different frameworks that offer some certain real-time capability. Maybe you've heard of Phoenix framework that has live data and it's all very shiny and cool. There's Meteor. Meteor used to be shiny and cool and is no more. Meteor is this JavaScript framework. It's pretty cool, but it had some flaws. That's for example. And then there's databases. Databases, for the most part, don't care about real-time data at all. There's certain certain databases that do, for example, Supabase or Firebase, where you can subscribe to some specific document or some row in your database to always get the most current value of that. But it's limited. For example, you could subscribe to one document, but there would be no way to subscribe to some complex query. For example, what you can't do at the moment is take your SQL query and say, I want that live. It's not possible. So database is not there yet either. And for libraries, so how to deal with multiple real-time sources and how to compute them and how to make queries across these. There's Reactive X. Like, who of you has heard of Reactive X? Cool. Who has used it? There we have it. And Reactive X is awesome, and we're going to talk about it later. But there's not a lot more. There's a question mark, and that's what we're going to fill in tonight. So again, real-time data, and we want to solve things. To solve things, we need to know what to solve, and it's example time. Let's be honest with you, like I'd love to use like an example from the chat domain, because that's what the story is about. But I don't know anything about the chat domain. I'm not a domain expert. And I suppose neither are most of you. So we're going to use a very contrived example that most of you are familiar with, which is Wikipedia. There's this amazing HTTP URL, which you can open up in your browser. And then it will give you a, oh, internet is working. It will give you a long string of all edits and changes that happen to Wikipedia. This is really cool. And it's very long, and it gets longer all the time. If we go to the bottom, we see, oh, it's going up again. So this is like a real-time stream of everything that happens. And if we have a look at one specific event, for example, this one, I did some work to like make that bigger for you. It could look like the following. It's just a JSON object. And it has a couple of fields. It has like an ID for that event. It has a type. This is an edit. It has a title, things like who was the user, who did the edit. There's a comment. So it's Smågevattnet Naturreservat, something Scandinavia, I think. A timestamp, and like these two fields, bot and mine. And there's a lot of other things. But point is, we have types, we have a user, and we have this bot flag, which tells us, was this edit made by a bot or not? Or made by a human for that matter. And I pose a goal for us tonight. I want to take all of the edits that come in real time, and I want to know what percentage of edits that are made by bots and what are made by humans, because I want to know who wins the race. Who edits Wikipedia, bots or humans? It's like the eternal question. And there's a couple ways on how to do this. I want to be upfront. If you just want to answer that question, there are easier ways to get there than by building a framework for it. But it's an example, so bear with me. This is where I want to introduce you to marble diagrams. Marble diagrams are really cool because they have a nice name. These are marbles and they are diagrams. And it's the preferred way to think about reactive X streams. And what is a stream? A stream is mostly like an array, but over time, or like a promise, but with multiple values. So the way this works is, let's take the top one on top, and I will use my mouse so I can actually reach it. This is the stream. It goes over time from left to right. Left is the beginning, right is the end. And over time, we emit some certain values. We're not going to think about timestamps, but like this is emitted before this one, and then this one, and this one in a time series. And on these streams, we can do some certain operations. These operations are very similar to collection operations you might know. Collection operations like .map, .filter, reduce, sum, every, you know those, the typical JavaScript array operations. And you can use those same operations to operate on these strings. So in our case, what we're going to do is we're going to take that initial stream. That stream is a stream of all the events happening on Wikipedia, and we're going to filter out to only have the ones that are edits. So we're going to filter for all the events with the type edit. And you see that most of them are edits, and then one goes out. And we have this new stream. And then with this new stream, we map to the bot field. So we take a look, is this event here written by a bot or not? And in this case, it is a bot. Here it is not, and here it is. And then to find out what the score between bots and humans is, who wins the race, we just aggregate on it. So we take a look at all of the events that are happening, and kind of like reducing over it. So we start at 0, 0, and then when a bot scores a point, we increment the bot counter. Then when like humans score a point, we increment the human counter, and so on and so forth. And another way to think about this is to split up the score into 2 streams. So you would have 2 streams that count both of the scores. The above one counts the occurrences of true, and the below one counts the occurrences of false. So this is at 1, 2. So at this point in time, we're at 2, 1. Like you zip them together, you just take the first stream, the second stream, put them together, done. And I really like this way of working with real-time data. You have those streams, you have operations, and the thing that results from the operations is your root stream, like the events that are coming in, plus all the operations and the query that is made on top of it. But there's one problem with it, which is it's kind of hard to think about it this way. We call this functional reactive programming. Functional programming because you start with one stream and you do some non-mutating operations on that stream to get another stream. So this to this is like functional in the same way that like filter and map are functional. And reactive means that we do it in real time. And working with this, again, it's fine, but you need to learn about all of these operations. And for some applications, it's just a weird thing to press things into. People need to learn about functional programming, all these things that typically cause mass hysteria. Just kidding. But what's interesting about this approach is that it resembles the idea of a dependency graph. Let me explain what I mean by that. The idea of a dependency graph is that you have up top the root source of all events. That is the Wikipedia changes stream. And then you have another stream that depends on the original one. So the Wikipedia changes stream is this one. And now this filter for edit stream, that depends on that one. So we have an edge between, like we have the dependency here. And whenever we make a change in this one here, whenever there's a new event, we know because of dependencies that we also need to maybe update this one. And then we can do the same to the end. So we have this human edits count that's dependent on the edit stream. We have this bot edits count that's dependent on the edit stream. And then in the end, we have this score stream that is, oh, does somebody have power for me? Yeah. Thank you. I should have brought some more power. Merci beaucoup. So then in the end, we have this score stream, which needs to update whenever either of these 2 updates, right? And I want to have this tie on the recording too. That was the lovely sound of juice flowing into my computer. Great. So it's super cool if we have this dependency graph, because once we have it, we know whenever something changes, we can exactly identify which of the other things we might need to update. So you might say, well, what's the problem? We have observables and streams and dependency graphs, and that's it. But the idea behind RTW was to explore how you could build a similar thing without this concept of functional reactive programming. Similar to, like, how many of you know React? Again, that's a lot. Nice. So if you use React function components, or if you generally use React, you have these strong concepts of functional programming, right? It's what you read all the time. React is like one-way data flow and all these fancy words. But when you write React, you wouldn't say this is functional programming. It feels very much, well, not imperative, but it feels like normal stuff. It doesn't feel like math calculus and academia mapped onto Haskell with functors and burrito monads. And the idea was, how can we take real-time data with a dependency graph, and similar to how React abstracts away the functional programming stuff, how can we create an imperative API for this? I'm not saying that's a good thing. I'm just saying we're exploring it. Okay, cool. So again, in written form, how can we preserve the idea of the dependency graph without forcing people into functional programming? How can we make it work with imperative code? And now I've brought 3 design examples, 3 little code snippets. All of them are pseudocode. Don't check for type errors or syntax errors. You won't find any. But it's pseudocode, and I want to walk you through these different design ideas we had and how we emerged at a design in the end. This is the first one, and it's a lot of code. Let's walk through it. So remember, we want to map to this concept of a dependency graph. And the idea we had is every class here is one of the nodes. It's one of the strings that can hold events. And the first one, which is a special one, is the one up top. It's the Wikipedia edit string. It's all of the edits that come into Wikipedia, and it extends live value. Don't worry about what it does. It does some magical things behind the scenes. But this is the only one that can insert data into our graph. And it will fetch Wikipedia. That's like, it will open some way of getting events from Wikipedia. Then for every line that comes in, it will send an event. This.send in this case will say, well, this node, this stream has something new. Please do something for me, framework, and update things accordingly. And that's a live value. It's where data flows into the thing. And now we have a derived value beneath the bot edits thing. The derived value does not have the option to insert any events itself, but it can derive its value based on other values, whether that's a live value or a derived value. It rhymes, which is cool. And the idea behind the bot edits is we want to count how many of the events that are coming in are performed by bots. So what we do is we put an instance variable. We initialize it at 0 because in the beginning it's 0. And then whenever this thing is derived, we take a look at the current value of Wikipedia edit, which is this thing here, Wikipedia edit.value. And then we take a look at, is it a bot? If it is, we increment. And no matter what's happened, then we return this.count. So what we return here will now be the current value of bot edits. All right? Following me? Yeah. Who is tuned out? Okay. So is there anything any questions I can answer so you tune in back?
This is supposed to be functional.
That's the thing. So it's supposed. So the question was, is this supposed to be functional? And that's the thing. It's supposed to be a mix. I don't think we can fully remove the idea of functional programming. And I also think it's not a good idea to try that. But it looks kind of imperative, I guess. It does, right? That was our goal all along. So we have the bot edits thing, and then we'd have a second class called human edits. It does all the same things, but it just increments when it's not a bot. So I didn't repeat it. And then we'd have the derived value called score, which when it's derived, it doesn't have any state, which you can see because it doesn't have any instance variables. And when it's derived, it takes a look at what the current value of bot edits is, and it divides that. No, it does the other way around, but it takes a look at what is the percentage of edits that have been made by a bot. And look at this line. I find it really cool because it's plain normal code. It looks like it looks very innocent, but it's real time, it's live. But we got fed up with this API because, let's be honest, classes are a bit ugly in this case. It's a lot of unnecessary code, and it also doesn't have support for some ideas like parameterized streams. Not going to get into that today, but it was a nice starting point. Mm-hmm.
To make the
Wait.
Hi. To make the dependency recognition, let's say, work, you would have to parse the source code of the derived function?
No, that's a cool thing. We are very clever at exploiting some weird features of JavaScript.
Which one?
Which is how all frameworks work, to not need to do this. So the way this would work is that we can get into this later on, and we can look at the actual source code. But the general way this would work is that whenever the framework decides to evaluate some or to derive some of these things, it would take note and say, well, we are currently evaluating this class. And then inside of why it's evaluating, the framework will see that you make a call to Wikipedia edit.value, because this .value, this comes from the framework. So we can make that dependency tracking. And what's also interesting is, you know that rule from React where you can't have React hooks one level deep? This is fine for us, because if it's one level deep, if it's under some condition, we just see, well, it's not used anymore, so that dependency apparently is not relevant. And then we can update it for the next time. That's mostly how it works. That's the basic idea.
Thank you. Answer my question.
Cool. All right. So this is the second API we came up with. This doesn't use any classes any longer, but it has these magical wrapper functions, make live value and make derived value. And as you might already see, make live value is the same thing as extending from live value. And the first thing, the Wikipedia edit stuff, it works mostly the same, right? We don't call this .send anymore, but we use like the injected send helper function, but it's mostly the same. The interesting thing is this bot edits thing, because in a function, we don't have any state anymore, we don't have any instance variables. And that's when we thought, well, React does this quite nicely. Let's just steal what they're doing and introduce this use state thing. And we'd initialize the state at 0, and then it would have that wonderful deconstruction thing. And then whenever the Wikipedia edit, so now we don't need to do .value, but just call it as a function. So whenever that's a bot, we set count to count +1, we increment it. And then we need to return count +1. Anybody have an idea why we need to do this?
Chain. The chain brings.
No.
Async change is not synchronous.
Correct. So what he said is because it's not synchronous, it will not immediately be applied. It's the same problem that you have in React. So the idea behind these setter functions in React is that if you make a call to set count, that is the queue that React can use to know, well, this changed, so we might re-render it. And React will then re-render the thing, and in the next render, you will see the updated value. But because React components are not meant at all to have side effects in their rendering functions, that's totally fine. We can just re-render it how often we like. But in our design, we want to have that. We want to have side effects, so it's not fine for us to re-render it all the time. So that's why we need to return count +1, because we won't immediately see the updated value. And like, who likes this? Who finds it ugly? Thank you. I'm exactly of the same opinion. That's why we built this. But before throwing this, I remembered I should show you the thing below, because that is now even more beautiful. That derived value score is now just this wrapper around like bot edits by bot edits plus human edits. This is almost imperative code. Take away those weird things, these, how do you call it, Klammern? Parentheses, thank you. So once you take these parentheses, it's fine. But we still don't like this set count thing. So that's our next design. And to be honest, not a lot changed. I'll show you what changed. We changed that now make derived value. It does not any longer take only a function that does some things, but it returns a function it takes a function that returns a function. This is weird. Why can't, like, I think React developers are somewhat familiar to this concept, but the basic idea is that when this thing here is called, that's setting up the stream. It's initializing the stream. That's the first thing, what's done when this stream is initialized in some way, and it will only be done once. And in this initialization, we can just have variables. We have this variable count, and we can then use that later. And then what we return is this derivation function that we've already seen before. So what the framework will do is whenever bot edits is used for the first time, it will execute this thing, and it will get back this thing. And then whenever something changes, it can call this here, and this will have access to that variable. So what we've now done is the state that was before in use state, it is now in a closure. Closure is what we call it when some function has access to something around it. You can think about it. That function, it closes off some values and takes it with it, right? That's what a closure is. And who likes this more? That's so nice of you. Thank you. Because it's also what I like more. And this is the final design that we came up with. I don't think this is the most beautiful design. I think you could improve a lot of things, but it's fine enough for today. And I think if you think back of this idea of a dependency graph, it clearly maps to it. You have the stream score, you have the stream human edits, bot edits, and Wikipedia edit. But as opposed to RxJS, where you'd need to very explicitly say, this stream depends on that stream and all these dependencies, it is very implicitly here. You just use the stream, you call it, and then the framework does all of the recognition stuff. I think that's the sneaky bit. And enough talk, let's do a quick demo so you can believe me that this is actually working. I prepared the same thing you already seen, but working. So this is this make live value thing. We are at a TypeScript meetup, so it is TypeScript, obviously. It will contain values of the type wiki event. It has a user string, a bot field, and a minor field. And then it does some things to subscribe to Wikimedia. Don't worry about it. The important thing is it sends stuff, right? And now, to prevent you from looking at it, I will close it. And then we have that derived value that exactly as you've seen sets up this this variable and then calls gets the most current wiki event, takes a look at is it a bot, and because it's TypeScript, we know that it's Boolean. Nice. We can increment this variable and then we can return it. And this thing here is exactly the same, but with an exclamation mark. And then in the end, we have this bots versus human script, or this bots versus human stream, to be precise. It gets the amount of human edits and the amount of bot edits, and then it does some basic third-grade math. And in the end, we subscribe to it. Don't worry about this. It's about arguments. I said I won't talk about it. And then it logs all of the events to the console. And let's execute it. This is the live score of who is winning Wikipedia. You see that at the moment, we have 43% of bots coming in. And you see it's changing pretty rapidly. That's because we don't have a lot of data at the moment. And sometimes users, like humans, are active, sometimes bots are. And when I tried this the last time, it swung back and forth and arrived at around 37%. But maybe that was 2 hours ago. So maybe people are currently watching football or something. So this is a very live value, as you see, and it's updating very heavily. But it works, and it's exactly the code I showed you. So there's that. But because it's a bit boring to only show you this, I brought a second example. Now, what is if we want to have a different query? Maybe we don't want to know who of bots versus humans is winning the race, but we want to know what account, what user is winning it. So let's comment out some things here. And I brought a second one. This one here is about the top 10 active users. So it derives the most active users by setting up a record of usernames to numbers. And then it returns this derivation function, which takes a look at the most current action and then increments that count. And we have that top 10 active user stream, which just takes a look at that record and sorts it by the amount of edits, slices off the first 10 people and gets their usernames. And now if we execute that, we can cheer along the race to see who wins. We see Geograph is in the win, TKS for Fish is second, it declines to third, but Violiensis is on the rise. And you can do that in 4 bits, and actually it's pretty cool because at some, like, this is only bots, right? But
and can you filter the bots? Can you filter the bots?
This is only bots.
Can you filter them?
Yes, we can. Oh, that's a good idea. Let's take a look at the action. And if the action is a bot, let us just return a record and not do anything, right? This is a very simple change to this. And now if we run this, we see that apparently Amasuela is first. But Horse Eyes Back is in the rise. That's a good idea. I think this is the way more exciting one.
Now you know that these people are just editing Wikipedia in real time.
Or they just fake their bot headers. Yeah. I like the name Bibliomaniac 15. That's nice. Governor Porter. Is it the real one? Okay, so that's just a demo on this works, please believe me. And we're going to get back here. I have some takeaways for you. When you design a library or framework or whatever, it's great to start with a mental model. Think about what you want your developers or your users to think about when using it. In our case, our mental model was this idea of a dependency graph and the idea of getting values in and by the dependency graph, updating what we need. Then draw inspiration from prior art. Most people that built these things, they thought about it and they built really good things. For us, our inspiration was React. We wanted to recreate this idea of functional style, but imperatively looking. And when necessary, diverge from that inspiration, which we also needed to do in the use state thing. Then when you design things, explore different designs. Try different things, find where they're good, where they're bad, and then converge into one shared design. In our case, that was trying classes, trying functions, and then converging to functions. Also, specialize before generalizing. In our case, that meant when we started building this, we had this goal of finding out who the most active user on Wikipedia is, at least at the moment. And that was our goal, which we used to build and design that library. And we achieved it. After some time, you might find different use cases that you want to add support for, and maybe you need to change your design, and that's totally fine. But start with a special use case. And do what I'm doing today, talk about it, share it with other people. Show them what you build, get feedback, because feedback is super important for these things. You don't design for yourself, but you design for others. Remember Jan from the beginning? Didn't come up long. Yeah, so the truth is, the cold hard truth, RTW may be fine, it may not be, but whatever, it only solves some or a very small part of their problems. They still have the problem of not getting live data from their database. They still have the problem of, for example, WebSockets not being nicely supported in serverless deployments. And there's a lot missing. And I think that real-time data is a super interesting design problem. And I'd love to hear all of your problems, and if you have some ideas on how to solve them. So if you have problems or ideas, come up to me, tell me, I want to know. Okay, that's it. I hope I didn't go over time too much. A little bit, yeah. That's what mostly happens.
Okay, so maybe let's take one question if there is any, and then I'm gonna rush with the agenda because we're so ahead of schedule. There's no agenda anymore. So
Yeah. I want to see that on the stream later.
Save the camera. I want to ask you, how are you consuming the stream of events? Because like magically you have this send event, but actually how this fetch function that you created works?
So that fetch function that I showed in the slides, that is just to mock you. It doesn't work. It's but what's the secret source. So this is what I think this is what you're talking about, right? The thing that I put away. So it uses this HTTPS thing from Node.js directly, and you can use that to not only get the full response, but to get a stream of the response that comes in. So this will give you an incoming message, and then you can subscribe to the data stream, and you need to do some weird things with buffers, and it's slightly more low level than you might be used to. But it works.
Okay, but it's basically primitives of Node.js.
Yes.
In the end.
Yes.
Okay, cool.
Yes, but I'm pretty sure there are better libraries for this. I think this pattern is called server-sent events. It's about having HTTP streams that are just kept open to infinity. And I'm pretty sure there are better libraries.
And then is there any downside that you realize when you start making too many derivatives? I don't know how you call it, like the listeners of the store
of the streams, of the live values.
Yeah. Like what happens if you create too many of them?
We haven't tried.
Okay.
But you can try. That's one thing I could show you. So RTW is, because RTW, by the way, stands for Real-Time Working Group, which we're free. It is available at, no, not RTW, it's Knott/RTW. And it's this library that has a very nicely written README. Because it's not meant for production usage. Like, I want you to know that. And well, if you're interested, check out the code. I'm not claiming it's nicely written, but it works. And that's what a proof of concept is there for. Okay, thank you.
Thank you.
Very looking forward to the questions.
Yes, sir.